Cutters are one of the most important subjects in routing. They can be the make or break for your success with SmartBench. Understanding cutters and knowing which one to use and when to use them will make your jobs both accurate and reliable. Routing is a process where a rotary cutter removes material with a sideways action. In SmartBench's case, the cutter is mounted in the spindle motor, which is then fitted into the Z-head. So let's understand the basic terminology and parts of a cutter. You have the shank, the body, the flutes, and the cutting edge. So what is the purpose of the parts of the cutter? The shank is what the collet clamps onto to hold the tool in place. The body is simply the area of the tool that has the features on it. The flutes serve to evacuate chips from the cut, and the cutting edge obviously does the brunt of the work. To better illustrate some of the features of the router cutter, let's compare it to the more commonly known tool, the drill bit. The primary difference is that the drill bit only has to cut on the end of the tool, whereas a router bit has a cutting action up the entire length. A router bit spins much faster than a drill bit as well, so it has to be much more well balanced. To give you an idea of how much faster, the average cordless drill spins at between 1.5 and 2,000 RPM, whereas with a 6mm router bit, for example, that will spin at 20,000 RPM. For that reason, it's important that you only ever use a proper, well-balanced router bit in the spindle motor. To illustrate this, we're going to do something that you should never do. We're going to put a drill bit in the spindle motor. This is dangerous because drill bits are not perfectly balanced for the speed that the spindle motor spins at. This means when it gets up to speed, the drill bit will resonate and start to deflect and could possibly break. They're also long and weak in the body. As you can see here, the drill bit deflects by a dangerous amount. We didn't even get up to full speed here and we shut it off early because any more and there's a danger that the drill bit could break. The next thing we're going to talk about is the flutes. The flutes are similar on a drill bit and a router bit in the sense that they both serve to evacuate chips from the cut. However, the flutes on a router bit are also designed to cut material. On a router bit, the angle of the flutes also have a big impact on the finish of the top and bottom of the part. We'll go into more depth on this when we start talking about the different cutter types. Router bits will have different numbers of flutes. The most common is 2, 3, and 4 flutes. The number of flutes will make a difference to both chip evacuation and cut finish. More flutes means that you'll get a better finish on your parts, however, you will sacrifice chip evacuation. Less flutes will mean a rougher cut, but much better evacuation of chips. Chip evacuation is an important factor to think about, as better chip evacuation means that you can move quicker through the material. If your primary concern is surface finish, and you're worried about stringing in materials such as plywood, you may want to sacrifice the chip evacuation ability for more flutes, which in turn gives you more cutting edges. When choosing the number of flutes, chip load is another important factor to take into account. Chip load is the amount of material that each cutting edge will take off as it moves through the job. For harder materials, you want to use a cutter with a higher number of flutes to decrease your chip load and improve surface finish. You might also want to choose a cutter with more flutes and a lower chip load if it's a material that's prone to stringing, such as plywood. For softer materials, you can get away with less flutes and higher chip load for quicker cutting. It's important to note that some router bits will not be suitable for plunge cutting. By plunge cutting, we mean moving directly downwards into the stock material. This is because the cutting edge sometimes doesn't extend all the way to the center of the tool. This is a prime example of that. To get around this, you can either use a tool that's designed with center cutting in mind, or use a spiral or ramped lead-in in your tool path. The last thing we're going to discuss before we talk about the different types of cutters is the different materials the cutters will come in. There's two main types. You have carbide cutters and you have HSS cutters. Now HSS cutters are the more cost-effective solution However, they are softer and won't last anywhere near as long as a carbide cutter. Carbide cutters are more expensive, but will last a lot longer and generally tend to give a better finish. Now we're going to talk about the different types of cutters. All different types of cutters will either have a spiral flute or a straight flute. We'll talk a little bit more about what these mean now. Spiral flutes and straight flutes cut in different ways. The straight flute has more of a chopping action as it moves through the material, whereas the spiral flute has more of a slicing or shaving action. We'll illustrate this in a way that you might be able to relate to a bit more. I'm going to use a standard Sainsbury's tomato. The straight cutter has a chopping action, which is equivalent to using your knife to cut straight down just with pressure into the tomato. As you can see, if I just use pressure, as the straight cutter will, it will deform the tomato slightly as we cut. The spiral cutter will give a different cut as it uses more of a slicing action, drawing across the surface of the material, just like this. So let's talk a bit about the pros and cons between spiral and straight cutters. Now this is a huge topic and it'd be impossible to even scratch the surface in a video of this length, but we'll try and give you a good idea of the main ones. The part finish will differ between spiral and straight cutters. A straight cutter will not give a bias to the top or bottom surface of your stock material and will apply an even load to each. The spiral cutter can give an improved finish on one surface depending on the direction of the spiral. However, you will often sacrifice the other. This is because the cutter will either pull or push the material as it cuts. The next topic to cover is chip evacuation. Now a spiral upcut bit will give you far and away the best chip evacuation performance of any bit, which is why it's often a popular choice. This is because the spiral flutes will pull the chips out of the slot. The straight cutter, however, won't give you as good chip evacuation, but this can be balanced out with other advantages. The final thing to talk about is the lifespan and the ability to sharpen. Now the straight cutter has the advantage that you're able to sharpen it if it does go blunt. However, the spiral cutter does tend to last much longer from the factory due to the lower cutting forces that it needs. Within spiral cutters, there are a couple of different configurations which will give you different attributes in your job. You have spiral upcuts, spiral downcuts, and compression cutters. So a spiral upcut cutter has flutes that wrap around the body of the tool in a clockwise direction. This means that when the spindle motor is also spinning clockwise, these flutes and the cutting edges pull the material and the chips up. This is great for chip evacuation and also gives a very clean finish to the bottom surface of your stock material. In comparison, the spiral downcut bit has flutes that wrap around the body of the tool in an anti-clockwise direction. This means that when the spindle is spinning clockwise, the cutting edges push down into the material, that you'll get a better finish on the top surface of your stock material. However, a major downside is that this will compress the chips into the slot of your cut, which can cause job failure in a worst case scenario. This is dependent on the type of material you're using and won't always be an issue, so sometimes the benefits can outweigh it. A compression cutter does both. At the tip of the tool, it has flutes that wrap around in a clockwise direction. Then above that, further up the body, they change direction to wrap around anti-clockwise. This means that you get compression on both the bottom and top surface of your stock material. Remember, a compression cutter is only good if it's used correctly. Otherwise, there is no point in using it. In this diagram, the compression cutter is being used incorrectly. The upcut section of the cutter is in contact with the top material surface, thus causing chip breakout. In this diagram, you can see that the cutter is being used correctly. This is because the downcut section is in contact with the top of your material surface to push down and stop breakout. However, it does also mean that you need to pay particular attention to your feeds and speeds as to not cut too quickly, as this extra compression will seriously reduce its ability to clear chips. So now we've looked at the features of different cutters and what they do. Let's have a look at all the different types of cutters you can get and their applications. Generally speaking, we have end mills, ball nose end mills, engraving cutters, and facing bits. So let's start with end mills. This is probably the most common cutter you'll come across when routing, and their key feature is that the tip is flat. This means they can create slots and pockets with sharp corners. They can also be used for cutting out contours all the way through the stock material. So next, we'll cover ball end mill cutters, and the key feature of these is the rounded tip. These are used for creating slots and pockets with rounded corners. These bits are also good for surfacing 3D contours. The next cutter we'll cover is engraving cutters. Engraving cutters have a tip angle varying from 30 to 90 degrees, and they're used for contour engraving. These cutters are called face mills. They're characterized by being very large, normally with 3 individual blades, and they're used for very quickly surfacing large parts. These are obviously only a few types of the cutters that you can get, but we picked these ones because these are often the most common ones you'll come across. There's plenty of others, and it's also worth noting that all of these cutters can be found in the different configurations that we discussed in the previous section. In this next section, we're going to discuss cutter life. There are many different factors that can affect cutter life, including the hardness of the stock material that you're cutting, the quality of the material of the cutter itself, the heat built up in the job, as well as any specialist coatings that might be applied to the cutter. The most common cause for a reduced lifespan in a cutter is heat. You can control the amount of heat build-up in a job by paying attention to your feed and speeds and making sure these are properly set. You can tell if your cutter is overheated by the discoloration that will appear on the flutes and cutting edges. If you do see that your cutter has overheated during a job, then it's important that you stop using that cutter because the hardness of the cutter will be completely gone and the edge will deteriorate very quickly. In this section, we're going to talk about the importance of regularly checking your cutters. We personally recommend checking them before every use. When inspecting your cutting tools, you can use a couple of different things. You can use a microscope. Here we just have a very inexpensive and easy to find digital microscope. Or you can use what we prefer and find extremely effective and convenient, which is a jeweler's loupe. When inspecting your cutting tools, it can be difficult to know what to look for. So here are a couple of pointers with images. The first thing to look at is the corners. You can see here that this corner is nice and sharp. This next image shows that the corner is starting to show some signs of rounding. And this next image shows what a completely blunt corner looks like. It's when you get to this point that the cutter should be thrown away, as it will no longer produce a good quality finish on your parts. Once we're happy with the corners, we can now look at the cutting edges. Here, we're looking for signs of blunting or dullness, as well as obvious damage such as chips. If you do notice any signs of rounding or blunting on your tool, it is important to not continue using the tool, as a blunt tool causes overheating, and overheating can contribute to rapid degradation of the tool, as well as higher resistance in your job, which can lead to job failure. An overheating tool can also transfer heat to the spindle motor and other parts of the machine, which will cause damage further up the chain. Finally, check that the shank of the tool doesn't have any damage, as damaged shank can lead to poor concentricity in the collet, which will lead to bad accuracy and performance in your cut, as well as potentially decreasing the collet's ability to be able to hold the tool into the spindle motor. In this section, we're going to talk about measuring the diameter of your cutters. Due to the manufacturing processes, the actual size of the cutter can be slightly under what's stated. When you found out the true diameter of your tool, you can update the values in your CAD/CAM toolpath, which will give you much greater accuracy. In this instance, we're going to use a micrometer to measure the tool. However, this will only work for cutters with 2 or 4 flutes. As with a 1 or 3 flute cutter, you won't have 2 opposite sides to measure against. This, for example, is an 8mm cutter, which means it was likely manufactured from 8mm round bar. For this reason, if we measure the shank, we can see that we're quite close to the stated nominal. However, if we measure across the flutes of the cutter, we can see that we're actually undersized by nearly 0.1 of a mil away from the stated nominal. The final diameter we get when we measure across the flutes is the value that we'd put into our CAD/CAM software. So that's the end of this video. That's all we're going to cover today, but there is plenty more to learn on this topic. It is a huge one. We'll leave some links in the description if you do want to learn more, but we hope what we've left you with today will be enough to get you started cutting with SmartBench. Thanks for watching, and we'll see you in the next one.